spread water repellent. You see, it's already 15 seconds.
And I even think it's extremely water repellent.
Mm.
The drops are remaining on the soil surface without any movement.
Yeah.
So what's this?
This is a hydrophobic soil, and that basically means that water is not able to infiltrate in the soil. You can imagine if it starts to rain, that rainfall is ponding on the soil surface and that it simply runs off the slopes instead of infiltrating into the soil. That is not exactly what plants need. They need water, especially in certain parts of Europe. And so this is giving a lot of problems for ecosystems.
Yeah, and that's why we started the CASCADE project.
Exactly. CASCADE is focusing on study sites ranging from Portugal to Cyprus. And phenomena like shown in this sample are taking place in natural field conditions in several of these sites. We would like to understand the underlying principles. We would like to understand how we can prevent that processes like this are developing. And if they develop, we would like also to know how we can restore degraded areas.
The area here is called Randy Forest because it used to be a forest. It was full of pine trees and bushes. Today it's highly degraded due to three main reasons: cutting of the trees, drought and the overgrazing. Do you see that farm over there? It's a goat and sheep farm. There used to be more than 1,000 goats in there and sheep. And do you know why it's so wide, the mountain and the hill behind the farm? Well, that's due to overgrazing, because the sheep spend more time around their farm and they eat almost everything.
Τα μέσα είμαι που τρόχρονο που γεννήθηκα, ήμουν τα μέσα μέχρι σήμερα έχει 80 χρόνια. Τα μέσα η περιοχή πριν που έβρεσε, που είχε προβοκτώδεις καλές, είχε πλάστηση καλή. Η περιοχή παλιά τα είχαμε, είχε ωραία πεύκα και θάμνους μητσούς. Μέσα στη φάρμα τάζομονται πάλες και τριφύλια και σανούς και κρυθάρι και ξέρουν έξω και ανέβονται, ανέβουν και έξω δρόση. Ό,τι έβρουν να φάσει.
If you look over there, you can see a hill which is complete overgrazed. This is the ultimate catastrophe. There used to be trees, bushes, grasses. Now there is nothing. You can also see the paths of the goats. It's the only remain that it's been left on that hill. Also, due to overgrazing, erosion has started and it's showing its first signs on this hill. And as you can see, on the ground there is no soil left. There are only rocks. The problem with this is that the seeds from grasses or any other bushes or trees cannot grow on this type of ground because there is no soil to grow, to make roots. There is only rocks left in this area. This is a typical example of grazing. The plant is trying to grow up, but the sheep don't let it. The problem with the goats is that they almost eat everything. They even try to eat the leaves from plants that have plenty of thorns. Thorns where the humans, we cannot touch them. And the goats manage to remove the leaves from the plants that have thorns with their lips. And this is something incredible. What we are trying to do here is to find the tipping point in which the vegetation cannot recover due to overgrazing. So in order to do that, we do soil measurements and also plant measurements. The aim of the project is to find the threshold in which vegetation can recover or not. And when we find that, we will be able to tell to the farmers and to the sheepers that if an area has come to this point, there is no way back. The catastrophe has come. So the areas that are above the threshold may recover. So we will try to find some ways, and we have to speak with the authorities of the country here, and we will try to find ways to protect those areas, and we'll try to restore the vegetation in those areas, because otherwise the catastrophe will come through time.
En 1979 hubo una catástrofe en el monte, que es el hábitat natural de Ayora, que duró 4 noches y 6 días. 40% de la población vivía del monte. En casi todas las casas habría una persona por lo menos que dependía de trabajar algo en el monte. Había apicultores, había madereros, había agricultores. En una semana se perdió 15-20.000 hectáreas de monte aquí en Ayora, entonces es que fue catastrófico lo que pasó, sí.
Fijaos en esta parte de la montaña que tenemos enfrente. Así es como debía ser el bosque antes del incendio de 1979. Es un bosque maduro de pino. Está dominado esta parte por el Pinus pinaster, que es el pino rodeno, aunque también existen zonas de pino carrasco, Pinus alepensis. En 1979 tuvo lugar un incendio en este bosque de pino maduro. Y fijaos, esta zona ha sido quemada hace 35 años y seguimos teniendo pinos. ¿Por qué esto es así? ¿Por qué volvemos a encontrar pinos en esta zona quemada? Estos pinos mediterráneos tienen lo que se denomina piñas serotinas, que son las piñas se mantienen en la copa del árbol y con el calor, con las temperaturas alcanzadas en el incendio, abren las piñas y dispersan los piñones. Si los piñones, una vez dispersados, encuentran las condiciones ambientales adecuadas, pueden germinar y establecerse. Y eso es lo que estamos viendo aquí. Es un matorral denso, pero donde se han producido establecimientos de manera natural de pinos. Probablemente en el futuro podríamos tener otra vez un bosque de pinos. ¿Qué es lo que ocurre si tenemos un segundo incendio en la misma zona en un corto periodo de tiempo? Bueno, lo que estamos viendo aquí a la derecha. Los pinos han desaparecido porque no han tenido tiempo para producir suficientes piñones que puedan ser dispersados y establecerse nuevos individuos para formar ni siquiera individuos aislados. Además, la regeneración es muy importante del matorral, principalmente dominado por especies germinadoras que acumulan una gran cantidad de combustible fino y seco en su biomasa. Esto confiere al matorral un riesgo de incendio extremo. ¿Qué podemos hacer? ¿Qué herramientas de gestión se podrían hacer en este tipo de territorio? Bueno, en primer lugar, si el objetivo es reducir el riesgo de incendio, sería un desbroce selectivo de estas especies con alta cantidad de combustible y dejar los restos en la superficie de manera de mulch, un mulch orgánico que proteja el suelo de erosión, y además se podría complementar con la introducción de especies más resilientes, rebrotadoras, que han desaparecido en el pasado por el uso intenso que se ha hecho del territorio y que le confieren al sistema una rápida respuesta después de una perturbación como el fuego.
Okay, we are in southeast Spain, and these landscapes represent very well the degraded rangeland and woodlands that we have in the semi-arid areas of Spain. And the vegetation cover is very low. A large proportion of the surface is bare soil, and therefore the soil is not protected by the vegetation from the impact of the rainfall and wind, and is not protected from erosion caused by runoff. Because the organic matter content is very low, the soil is very loose. It can be detached very easily. And also it gets compacted because of the impact of the raindrops, and these again contribute to the loss of resources in the area. But the question is, what are the driving factors of this degradation, of this negative loop? What is the starting point? What did trigger in the past this degradation? And the first suspect could be climate, right? Because under a semi-arid climate with around 300 millimeters rainfall per year, like we have in this area, we cannot expect to have 100% vegetation cover. Not even 70 or 60%. So, but must be other factors, because we do know that with this very climate, we can have here a more developed vegetation, more diverse, healthier ecosystems, better soils. And how do we know this? Because there are some remaining patches of this type of healthy vegetation. Yeah, this patch here is a good example of the type of vegetation that we may have. We see 4 different species of big shrubs, and these big shrubs are very important for several reasons. They provide food and shelter to animals, so they contribute to animal diversity here. But more important than that, they work as ecosystem engineers. And that's it, that they create a special microclimate under their canopies. It's an improved microclimate. And also they improve the soil condition. This soil receives nutrient input from the litter of these shrubs. So the nutrient content in this soil is much higher than in the degraded area that we saw before. So conversely to the degraded area, what we have here is a positive loop. Why these patches are here in the middle of this degraded area? Yeah, mostly because the rocks in this area protected them. People in the past used to remove these big shrubs for gathering wood, or the goats that we have here in the park used to browse on them in a very heavy way, a repeated way. But in this area, because of the big rocks that we have here, they are being sort of protected. So the second suspect is the human activity. How can we restore this degraded area? Well, what about to mimic nature? So what we did here is we planted few shrubs and waited for their capacity of improving the conditions in the area. So they improved the soil here, they created improved microclimate, and this helped other species to thrive here. So these plants here, like this legume species, which is very important for the functioning of the ecosystem because it provides nitrogen to the soil, or these other species came taking advantage of these improved conditions in this area that were created by the few shrubs that we put at the beginning. So we just started the process. We just triggered the process. And then these ecosystem engineers did the rest of the work.